Welcome to another episode of learning. Please like my videos and share them with your friends and colleagues. This is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Numerical Analysis, and the problem is related to the Forward Euler Method. This question is placed in part C, which is a multiple select question. There may be more than one answer. The question carries 4.75 marks. The question ID is 562954171. Further, this question is suitable for all these examinations. Right. The given question is: consider the initial value problem, IVP for short, y prime plus y is equal to 0. The initial condition y at 0 is 1. Let the sequence yn be the sequence of iterates of Forward Euler method applied to this initial value problem with step size h, where 0 less than h less than 1. Then which of the following statements are true? Right. We are given 4 options. Option 1, the sequence yn does not converge. Option 2, yn tends to 0 as n tends to infinity. Option 3, 0 less than or equal to yn less than or equal to 1 for n is equal to 0, 1, 2, etc. Option 4, modulus of y of nh minus yn tends to 0 as n tends to infinity. Right. Let's now discuss the solution of the problem in detail. We have the given IVP, y prime plus y is equal to 0. Y at 0 is 1. That is, y prime is equal to f of xy, f of x comma y is equal to minus y, right? And y naught is equal to y at 0 is 1. The Forward Euler method, which we are very familiar in the numerical analysis, the Forward Euler method for the differential first order differential equation y prime is equal to f of x comma y with the step size h, where 0 less than h less than 1 is given by y n plus 1 iterates is equal to y n plus h times f of xn comma yn. Right. This implies yn plus 1 is equal to yn plus h into f of xn yn. F of x comma y is minus y. F of xn comma yn will be minus yn. Therefore, minus h times yn. And yn is common, 1 minus h multiplied by yn. Now, thus we got yn plus 1 is equal to 1 minus h multiplied by yn. Right. Given y naught is equal to y at 0 is 1. Yeah, this is the initial condition given to us. Substitute in this. That is, n is equal to 0, you substitute. y1 is equal to 1 minus h into y naught. Right. Y naught value is 1. That is 1 minus h. Right. N is equal to 1. Then it will be y2 is equal to 1 minus h into y1. That is equal to 1 minus h whole square. Continue like that. In general, what you get is yn is equal to 1 minus h to the power of n, where n belongs to set of natural numbers. Right. We continue the discussion in the next slide. Right. What we have is yn is the nth iterate is 1 minus h to the power of n. N belongs to n. Call on option 1. The sequence yn does not converge. Option 2. Yn tends to 0 as n tends to infinity. Option 3. 0 less than or equal to yn less than or equal to 1 for n is equal to 0, 1, 2, etc. Right. Right. We discussed now. We have 0 less than, h less than 1. Correct. Now multiply throughout by minus 1, where the inequalities will be get reversed, and that will give rise to minus 1 less than minus h less than 0. Add throughout 1 minus 1, 0 less than 1 minus h less than 1 plus 0, 1. So 0 less than 1 minus h less than 1. Agreed. Agreed. Now take yn, take the limit. Limit n tends to infinity of yn is limit n tends to infinity of 1 minus h to the power of n. But 1 minus h value lies between 0 and 1. Therefore, it tends to 0. So it will be 0 because 0 less than 1 minus h is less than 1. Correct. So yn tends to 0 as n tends to infinity. Thus option 2 is true. And option 1 says the sequence yn does not converge, but it is converging. Therefore, option 1 is not true. Agreed. Now, 0 less than 1 minus h less than 1, yes. So, raised to the power of n, where n is a natural number. 0 less than 1 minus h to the power of n less than 1. For n belongs to n, that is n is equal to 1, 2, 3, so on and so forth. Now, that means 0 less than 1 minus h to the power of n is yn less than 1 for n is equal to 1, 2, so on and so forth. In option 3, it is also included less than or equal to. So, why not we take? So, n is 1, 2, 3, so on and so forth. 0 less than yn less than 1. Now, why not? N is equal to 0. N is equal to 0. Y naught is 1. Therefore, this end is included. This end 0, yn less than or equal to 1. For n is equal to 0, 1, 2, 3. Above 1 is 1, 2. Now we have included y naught also. So, less than or equal to 1. 0 less than, yn less than or equal to 1. Thus, look at the option 3. Yes, option 3 is true. Option 3 is true. Agreed. We are left with last option. So far options 2 and 3 are true. We move to the next slide. Fourth option. Modulus of y of nh minus yn tends to 0 as n tends to infinity. What is this y? Y is the solution of this differential equation. That is you solve it and get a solution, that is y. That is y. So take the differential equation. Y prime is equal to minus y, right? And 1 by y dy by dx is minus 1. Integrate on both sides with respect to x. Then you'll get log y, ln y is equal to minus x plus ln c. Right. So that is ln y is equal to ln c into e power minus x. That will give rise to y is equal to c e power minus x. To evaluate c, we take the initial condition. We are given y at 0, the value of y at 0, x is equal to 0, is 1. Substitute in this. Substitute in y at 0 is 1 is equal to c into e power 0. So it is c. C is 1. So therefore the exact solution of the given initial value problem is y is equal to e power minus x. So now y at nh, is equal to e power minus nh. That's equal to 1 by e power nh. Take the limits on both sides as n tends to infinity. Limit n tends to infinity of y of nh is equal to limit n tends to infinity of 1 by e power nh is 0. Right. And we have already seen limit n tends to infinity of yn is 0. In the option 2, we have already seen. So therefore, limit n tends to infinity of y at nh minus yn will be limit n tends to infinity of y of nh minus limit n tends to infinity of yn, that is 0 minus 0 is 0. So y of nh minus yn tends to 0 as n tends to infinity. Therefore, modulus of that also tends to 0 as n tends to infinity. So modulus of y of nh minus yn also tends to 0 as n tends to infinity. Therefore, option 4 is true. Right. So summarizing all the options, the answer to this question is options 2, 3 and 4. That is the detailed discussion of the solution of this problem from the section numerical analysis, which is based on Forward Euler method. And I've been telling you in the past some of the videos, the questions from numerical analysis are appearing in part C and part B also. And many a times these questions seems to be very, very easy. So I said a strategy for some of you is, to all of you, is that you study the numerical analysis, remember the formulae, and that will help you. And try to attempt questions from numerical analysis. They will be very easy. I hope that you take my advice seriously and pursue numerical analysis. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Right. This is my channel. Please subscribe my channel. Yes, I am sure I will meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.